Okay, so here we are. Ignore this was for the other class. Exam 3 is, I think it's next Tuesday, isn't it? Tuesday after next, I mean. 28. Isn't that what our exam is? What does it say? You guys are living and die by this thing, right? No? Pay attention to this thing?
Folder, but I don't have it up. Right.
28, yeah, 28. Exam 3 is 20. So week after next, on Tuesday, is exam number 3. So we have exam 3, exam 4, and the final. So there are some points left. All right, let's get into half-life of radium, 1690. Did we do a half-life problem last time? I don't think we did we? No. So, all right. So we'll dive into, what's the formula we're using? It's the PERT, huh?
Yeah.
Just keep using the PERT all the way through this section. Keep using the PERT formula. All right, so there's the PERT. And remember, we do these in 2 phases. So phase 1, in fact, I'm not leaving myself very much room. Let me move it on up there. So A equals PERT. Going to use that for all these exponential growth ones. Phase 1 is find R. Get your hands on R. So how do I do that? Well, I'll plug in the information. They're telling me, I've kind of written over the top of it now, 1690 years. So when time is 1690, do you guys know what half-life? Maybe we're talking about that for a second. What does half-life mean?
How long it takes half of it?
Yeah, how long for half of it to vanish? Yeah, so they said, so if you have a clump of this radium, there's a clump. Does that look like a clump? I'm really artistic. I don't know if you can tell. My art career ended in 7th grade with a C, and I was trying. I don't think he appreciated my style. Anyway, so like say you had, I don't know, 26 grams of this stuff, this radium stuff, okay? If the half-life is 1690, half-life 1690 years, is that on the screen? No. I don't know why it's really cutting off my screen these last couple days. It's like it shifts day by day. Anyway, that would mean, is that a little bit more? Yeah. That would mean there'd be 13 grams, right? Half of it left after 1,690 years. So that's what half-life means. How long for half of it to go? And then in another 1690 years, there'd be what? 6.5? Half of 13? 6.5 grams. Little pile. Shrinking pile. Does that make sense? So it's not subtracting the same amount every time. It's losing half of its amount every 1690 years. So that's what half-life 1690 years means for any substance. How long for half of it to vanish? Okay, so if that's the case then, what is the amount when half of it has vanished? Yeah, 0.5p, half p. Use fraction or decimal. Decimal is usually easier, I think. So I'll just do 0.5p, right? Now, the mistake I see a lot of students make on the test, they go 0.5. That's not right, right? That'd be like if I said to you, you ready? Half. What would you think if I just said that all of a sudden? Half. Yeah, you go, half of what? There's no such thing as half floating by itself, right? So same thing. Don't put a 0.5 floating by itself. It's half of something. It's half of the original investment, huh? Half a p. P's the principal, like in money, it's the original investment. So it's 0.5p. That's important because your first step will be to divide p out of both sides, huh? So students that forget to put the p there, then they get stuck. They're like, oh no, how do I get rid of that other p? And they get all messed up and the whole problem goes bad. So that's why I've noticed that over the years, really messes people up. So don't forget that, 0.5p. There's no such thing as a half by itself. It's half a p, right? Half of the original amount, right? The amount now, 1690 years later. So when time is 1690, the amount has become half of the original amount, huh? Divide the p off both sides, so we have 0.5 is e to the r 1690. But what's phase 1 about? Finding r. How do I now find r? How am I going to solve for r? Yeah, where is r? He's climbed into power, right? And so what are we going to do? What's going to get him out of power? The natural log. The natural log will dethrone the power, right? That's the trick. That's the trick, right? Got to get him out of power. It's all about getting him out of power. All right, so we get to here. Now we can, so L and E just 1, huh? So that doesn't matter. So just divide by the 1690 now. We good? So R equals ln 0.5 over 1690. So there's R. We got our hands R. Now, you could get a decimal, but let's don't. Because see what they say here? All right, do not round in the beginning. Don't round to the end. That's important. I don't want to get that ln 0.5 over 16 and get some decimal, because the decimal will go on forever and I'll have to round. And they want me to not round until the end, because it'll throw other things off quite a bit, because that's going to end up being in a power zone in a minute. And so any rounding for something in the power is going to have a big effect on the final answer. So it's best to not round in the middle. Instead, just leave it like that. So there's my R. So let's go to phase 2 now. What's phase 2? Once you got your hands on R, that was the goal of phase 1, right? To find R. We've got it. Phase 2, you start with the same formula again, but now you stick in your R that you found from phase 1. Does it make sense? These will always pretty much work this way. Yeah. Phase 1, use the PERT formula, find R. Phase 2, start the PERT formula again, plug in the R. So, the R, ln 0.5 over 1690t. Does that make sense? So now, remember the trick I showed you guys last time? You guys never forget anything I say, right? You guys play these videos back all day long, right? In your house for entertainment at night? Let's don't watch a TV show tonight. Let's watch Mr. Heron's exponential growth and decay lecture again. Try it with your family. They will be so impressed.
I did play it for my husband.
You
It's
did?
actually my class. This is what it sounds like.
That could be detrimental to your marriage. All right. So the E cancels the natural log. Right? Remember that little trickery? I want to stop and camp, and so I'm telling silly stories. So I do want you to remember. It confuses a lot of people. The E cancels the natural log, but remember, the 1690 is not in the toaster. That's the part that confuses people. They know that. I mean, I think what I've seen over the years is people remember that E cancels natural log. They remember that much, but they get a little confused on exactly what happens then. I want to really be clear with you. The 0.5 drops down, and the T over 1690 stays in the power. That's the part that seems weird to them. Let me try to make that make more sense for you. Why? Because the 0.5 is in the toaster, so to speak, in the natural log function. The 1690 is just sitting underneath it. It's not in the natural log, right? So the T and the 1690 are kind of outside of the natural log thing. Does everybody see that? It's not, neither the T nor the 1690 are in the natural log. They're just around it, right? So when I cancel E and natural log, the 0.5 is the only thing that was in the toaster when I apply the detoaster to the outside and knock off the toaster. So out comes the bread, out comes the 0.5 only, and drops down to the base level. Is that good? I'm off the screen. That's just really an abrupt screen. I mean, it's like,
Over there, you're not.
yeah, it's really abrupt here. I should throw something at that projector and make it move. All right, that's how I handle technology. All right, so anyway, so we got that formula. Good so far? So there's our formula. Now, what is their actual final question to me? Oh, how much in 690 years? How much will be present in, 80 grams now. Kind of written all over it. 80 grams now, so that's the P, huh? So here, can I go to a new screen? Everybody got that copy down? A equals P, 0.5 to the T over 1690. So let's do that. So A equals P times 0.5 to the T over 1690. So everybody got that copy down okay? All that, so again, so on these PERT problems, these growth and decay ones, phase 1, use the PERT formula, find R. Phase 2, plug in R to the PERT formula. Clean it up a little bit. Let the E and the natural log cancel, and what was in the natural log drops down to the base. Now, having said that, let me give you a shortcut. Do you see how we got to here now? For half-life problems in particular, for half-life problems, it'll always be, if you want to skip all that, it'll always be 0.5. See, the 0.5 is the half. Right? That's where that came from, the half. T over the number of years for half-life. Probably way off the screen there for half-life. It'll always be that. So if you want to just jump right to there. Now, not all the problems in this section are half-life problems. Probably out of 10, maybe 3 are half-life, maybe 4, 3 or 4. So I'm not saying this will work for everything. I'm just saying for the half-life problems. If you want to skip phase 1, basically. If you want to skip phase 1 and just jump right to your half-life formula and just wrap up the problem quick, it's always going to be this kind of format. It's always going to be, PERT, but the 0.5 will become the base because that's the half. And the T over the number of years in the half-life, like we have 1690 underneath the T. It'll always be that format. But again, that won't solve all these problems, right? I made that mistake. I was trying to help my daughters. They took pre-calc last year from Mr. Greg Jameson. Mr. Jameson, my good friend across the hall from me. And they were taking him. And so I helped them get ready for one of their tests. They had growth and decay. And they were doing it the hard way. I'm like, girls, let me give you a little shortcut that'll work for all the half-life problems. So I set this up. You don't need to do all that stuff. Just put the point. They were doing the whole thing. Just put the 0.5 there. See, that'll always work for the half-life. I remember my younger daughter, Lizzie, saying to me, so Dad, what if Mr. Jameson, because Mr. Jameson's tricky. He really likes math. He likes math better than me. He's probably the strongest mathematician in the department. He really likes math. He really enjoys it. It's a lot of fun. Anyway, but he also challenges students on the test. And so Lizzie was like, what if Mr. Jameson doesn't give us like a half-life on there? Or what if he doesn't do it in that format? And I'm like, oh, he probably won't because they were in the homework this way, She's like, I just want you to show me the long way. So I'm like, no, we don't got time for that. This will work. Then they took the test, and sure enough, he put it the long way. She was all mad. Dad, I told you. Anyway, so I'm telling you clear, it won't always be this way. It won't always. So this will work for just the ones where it says half-life in particular. But the other 7, you have to do all of phase 1 still. Make sense? Was there a question?
Yeah, you can't go back one.
Back one.
You already erased that last one.
You want to see that?
Yeah, okay, so saying L of n divided by 1690 times t, is that the same thing as saying L of n times 1 over 1690 times t?
Yeah, good way to put that, David, right?
Yeah,
that's a good way to put that. Yeah, and sometimes I do it that way if it's more helpful. If you like that, well, even maybe better, you could just move that 1690 right out here. Does that look better? Is that better to your eyes? Because you're right. Because really, these are just 2 fractions, right? It's just like a over b times c, and I said, hey, that's the same as a times c over b. I just moved the b over there. That's kind of like what I just did. Does that make sense?
it makes it easier to set.
Yeah, it does, to kind of, with your eyes, huh? I agree. Yeah, so if you prefer that, then these boom, and the 0.5 comes down. Right, do that if that helps. Yeah, because that's you're right on. That's all it is a couple fractions. I'm just moving the denominator over. That's all I'm doing. Yeah, good. Thanks for that comment. Okay, getting back here then. So, now, let's finish it up. 80 grams present now. That's P, huh? That's present now. And and what's the T? Oh, 690 years. So in 690 years, how much will there be? 690, and we still have the 1690, is because that's already the bottom. That makes sense? Just hit buttons on your calculator. Can you get that? Somebody got a number there? 16.33? What you getting? Okay, good. Thank you, Terrence. Thank you. 60. I don't know how many. Oh, thousands. Well, give me one more. 1633. 1, and then it doesn't round up or anything?
No, it's the next
That's
one.
correctly rounded. Okay. There we go. You guys, make sure your calculator can do that. Glad to help you. Some people had some trouble on this exam. What number was, well, it was different on the yellow and the blue test. And with the graphic calculator. Yeah. What's that?
It's not bad.
Isn't it? What you get, Smith?
60.281.
60.281? Yeah, it seems small to me too. I think you're right. You guys able to get that now?
What did you turn wrong?
Yeah.
I don't know.
Everybody figure out how to do that? 60.281. Anybody else getting that? Yeah? Okay, a couple people up. Can I help? You guys able to get that?
Is that wrong?
Okay, yeah.
Oh,
See,
okay.
there's a little mistake.
What
See,
did you
with
win?
the structure.
I
See how you have
gotta put
parentheses
it
around
in
it?
parentheses there.
That means that.
I forgot to do that.
Because you're using it.
Yeah, so just knock those outer parentheses off and you're good. Yeah, is it good? Please come see me on that. Grab me after class. I mean, I understand you don't all have time to run by my office, but like 5 minutes after class, if you're having trouble getting those on the calculator, just grab me. 10 seconds. Boom, we can straighten it out. You'll be rolling. I know on the last exam 2, there was that graphing camp. One of those was just graph it, find the max, and like a lot of people missed it, majority. Right? If you still haven't mastered how to put something into your graphing calculator, graph it, and see the max, and know how to adjust the window, come see me. You know what? I had a young lady come see me today. We had a fun time. It was good. I didn't yell at her. I was nice. I was glad to help her, right? Come see me, right? I'm paid to do it. I'm glad to do it. Come see me. I'll show you how to do it on the graphing calculator. She'll nail it on the final now, right? I showed her how to do the window thing. So make sure you can do these things on your calculator. No, it's just needless loss of points to not know how to graph and punch the buttons and everything. All right, we don't got time. Is that what it is? Yeah, the parentheses. You got to be careful with all those parentheses. All right, half-life, carbon-14, 5,600 years. Hey, this is half-life. Can we do the trick? That made my daughter so mad when you had to do it the long way. We'll do the long way a couple times too. But let's do two. So for half-life, remember what I was telling you. It's always going to be AP 0.5 for the half to the T over the half-life time. It's always going to be like that. You can just skip phase 1. Skip phase 1 for half-life problems. So it's P 0.5 T over, what was half-life, 5,600 years? Boom, there's our form. That's what would come out of phase 1 if we went through all of phase 1. That's what we would get for a half-life. It's only for half-life because the half is the 0.5. Okay, can you finish it then? It's a little tricky. It's different. They're being tricky. Let me give you a second. You'll get more out of it if I give you a second instead of just talking right away. Okay, so yeah, this is tricky. They're saying this is how we're basically carbon dating. Here's a carbon dating problem. This is how they carbon date. Basically, I'm not a biologist, but I've heard the basic structure. I can do the math part of it. The basic biology fact is there's two kinds of carbon in living things, trees, people, animals, all living items have two kinds of carbon. One kind starts decaying at the moment the thing dies. At that moment, the carbon starts going with the carbon-14, starts decaying. And then there's another kind of carbon that stays steady. I don't know what it is, I forget. But that's how they compare. So when they find a piece of a tree that was once alive or anything else, they can compare that one kind of carbon that stays put with the carbon-14. Because that way they know what the other carbon-14 started out being, because they have the other one which hasn't changed. Am I making any sense? So they look at, oh, there's 10 grams of the other one, so there must have originally been 10 grams of the carbon-14 as well. Now the carbon-14 is down to 7 grams, and that's like a time clock. They know how fast carbon-14 decays. They can figure out how long ago the thing died. It's more complex than that. That's my simple overbrush, but that's generally what we're doing. So they're telling us, okay, they found this piece of charcoal, right? That's a burned tree. A tree was once alive. And it shows that only 63% of the carbon-14 expected in living matter. So in other words, it's down to 63% of what it should have, what it originally had. So that's like a time clock, because we know it goes down to half after 5,600 years. That's the half-life of carbon-14. So with that, we can figure out how old the thing is. It hasn't gone down to half yet. It's still got 63%. So it's not 5,600 years old, is it? It's probably around 2,000 or something. And now we'll get the nut. But if you see how it's good to have a ballpark before you. That way, if you hit the wrong button on the calculator, get something crazy like 57,000, you're like, no way. No. I know the answer is right. It goes, half of it goes away in 5,600 years. This is less than half of it has gone away. Right? It's still got more than half of its stuff. If it's carbon-14, it's got 63% still. So maybe it might be like 4,000 years old. You know, but it's not 5,600 or more. Or it would be below 50% left, right? You with me? All right, so anyway, how do we find the exact? Well, what amount is left? Well, 63%, right? Is that good? The amount left is 63%. Okay, can you solve? Can you solve there? Let me give you a chance. Solve it up. What are we solving for? Yeah. The tree died how many years ago? And it says when. It's off this screen. It's probably, yeah, when. When. When means time, huh? When. How many years ago? What is time? So solve this equation for time. Solve it for time. Go ahead and solve it for time. I hope you're having some difficulty. I assume you're having some difficulty because I'm doing something crazy. But I'm doing it on purpose because this is what I see all the time.
I was going to harsh you getting the P.
Very good. I know I just beat that drum, but I want to beat it again because I see it all the time when I grade tests on this test. Right? Again, be real with me. What if I said, guys, 27%? And I just said that. You'd go, 27% of what? Exactly. There's no such thing as 63% alone without a P. What does that even mean? Right? Percentages, half, 63%, all those have to be of something, times something, or they're meaningless, right? So don't forget the P, and that helps you because then you divide out the P on both sides, and away we go. Now we can solve for T, right? That's what happens to a lot of people, though. Seems silly, I know, but I have seen it and seen it and seen it again. Samantha?
Could you just automatically put .63 in?
And just cut out the P's. Totally fine. Totally fine. Yeah. No, that's great. I don't care. I'm never picky. But I've seen a lot of people put it on one side and not the other, and then they're deer in the headlights. They're frozen, and they don't know what to do. So don't make that mistake. Yeah, either way is great. You're right, Samantha. All right, so take it from there. Can I go to a fresh screen? So .63. So we got .63. Here, I'll put the P back in there. P, what was it, 0.5 to the T over 5600. Yeah, so we cut out, divide out the P on both sides. So .63, 0.5 to the T. So what are we going to do now to solve for T? Now we get rid of those P's, we can do it. So what do we do? Yeah, T is in power. T is in power. Got to get him out of power, right? Got to get him out of power. You know, I think I might have mentioned already. I'm listening through Winston Churchill's biography now. I love this. I'm a wannabe history teacher. Give me 20 seconds, right? And I'll get right back to math. So, and Winston Churchill. You know, I don't know if you know the history. I think it's a very interesting time period when Germany was battling England and all that kind of stuff. Anyway, and Hitler was furious with Churchill. I don't know if you knew that. I didn't know how much that was the case. And he used to say, you know, he kept wanting England to surrender, because he was having trouble beating them. And he wanted them to surrender. And he felt like they would have surrendered if it wasn't for Churchill. And his, we will fight, we will fight, we will fight, we will never stop until we are just wiped out. We will never surrender, we will never sign a treaty, we will never. And that made Hitler furious. In fact, it was the end of him. He couldn't take out England, then he tried Russia, you know the whole history. Anyway, but it's so funny, because Hitler, here's a quote from Hitler. He gave a speech one time, and he said, I like those Englanders, Hitler said. I like those Englanders. He wanted them to surrender, is what he wanted. I like those Englanders, except for that Churchill. That was always, and he wanted, and he would actually threaten England and say, if you will just remove Churchill from power, then I will quit bombing your cities. Just remove Churchill. But he couldn't get Churchill out of power. Anyway, so there, I used that because I really want to tell you about history. Anyway, I just think it's very interesting. I would do history if I had to do over again. But I like math too. Let's do the math. All right, so that power that gets it out of power, right? Hitler could not get Churchill out of power. But we can get it out of power with the natural log. The power drops down. It's out of power. So now it's cake. Well, kind of cake. We got to solve for T. So we got to divide by that natural log of 0.5 on both sides. Zippo, right? Then we got, what do we got? Natural log 0.63 over natural log 0.5 is T over 5600. So what do we do now to finish getting T alone? Just multiply by that 5600. We good? Multiply. Am I off the screen? I'm off the screen. I'm always off that little silly screen. Multiply both sides by 5600. So there it is. So just hit the buttons on your calculator now. So 5600 times that ln of 0.63 divided by ln of 0.5. You guys got that? And we'll know how many years. And we're expecting something under 5,600 years, right? Maybe 4,000. I don't know. 3. What do you got? 3. 733. I think they say round to the nearest whole number. Yeah. So that's. Is it 0.5 or 0.4? Or?
0.8.
Oh, so it was 2. Or is it 3.8?
It's
2.8.
732.8.
Yeah, 2.8, so you're totally right. It rounds to what you said. 3733. Yeah, just round that 2 up. So there we go. That many years old. So it's a time clock to know how old the thing was. Is that good? Questions on that? All right. All right. Under certain water conditions, the free chlorine swimming pool decomposes according to law. Blah blah. Whenever they say decomposes, we're talking about exponential decay. We're going to use the PERT formula. It's the same old kind of thing. It's not half-life though, is it? It doesn't. I don't think so, right? It doesn't say half-life anywhere, does it? So this is not a half-life. So that means we're going to have to do phase 1 the long way and phase 2, right? So phase 1, you know how phase 1 works, right? We use the PERT formula. What's the goal of phase 1? Find the R. Find the R, right? The goal, so last problem was a half-life. We have that shortcut formula, the 0.5. But this is not a half-life, so we have to do phase 1 on our own. Okay, so let's do it. So what does it say? It says, tested the water, found the amount of free chlorine, 2.5. 24 hours later, and it was down to 2.2. All right. So basically what that means, you don't need all those other words. They're basically saying, look, it was at 2.5, then, what, 24 hours later? 24 hours later, it was down to 2.2. That's all I care about. That's all that's really relevant to me. That'll let me know something about the rate, how fast that chlorine is breaking down in the pool. So it started at 2.5. 24 hours later, it was down to 2.2. That tells me, with that, I'll be able to find the rate. Do you feel that? Because that's showing you how fast it's breaking down, right? So that means, okay, what was the P? What was the initial amount? It was the 2.5, huh? And what was the amount later? 2.2, and that was in 24 hours. Everybody see that? I put in time, 24 hours, for initial investment or initial amount of chlorine, 2.5, to become an amount 2.2. So I can use that to solve for R. How do I solve that equation for R? What do I do? What's my first step to solve that for R? Yeah, divided by that 2.5. Is that clean? I think that's clean. Do you have a calculator? If it's clean, I'll use it. If it's a decimal that goes on forever, I'm going to leave it as the fraction. Because remember, I don't want to round halfway through the problem. So is it clean? Somebody have it? I think it's clean, though. What is it? 0.88. And it just ends, right? 0.88? Yes. Nice. So then we'll just use that since it's nice and clean. So where are we at? So we're at 0.88 is e to the r 24. You know the drill. Got to get the r out of power. Got to get Churchill out of power. So natural log both sides. And the power is dethroned. R24 ln e ln 0.88. Like that. Ln e is 1. We get to there, right? And then last step to solve for r is divide by that 24. Boom. There we go. So we got our hands on r. I'm going to leave it just like that. I don't want a decimal, remember, because I don't want to round. That's just the end of phase 1. So now we need to go to phase 2 and plug, use the PERT formula again and plug in that r for my r in the PERT formula. And okay, everybody got that copied down? Can I go to a fresh screen? So go ahead and do part 2 now. Go ahead and do part 2, phase 2, which means plug in the R and finish up. What's their final question? It says, there's actually a couple of questions. So let's do this one first. What will be the reading after 2 days? That is 48 hours. So you want to take the PERT formula and plug in time 48 hours. Plug in the R we now have and plug in time 48 hours. We're in hours, by the way, right? We got to stay, whatever time unit you begin with, you got to continue with that same one. The original, I plugged in 24, so I was using hours. So I got to continue to use hours. So plug in, for 2 days, plug in 48 hours. So plug in that R, plug in 48 hours for time, and find out how much chlorine there is, how far it's decomposed. So we got the PERT formula. I'm going to plug in.
What does that say when the chlorine level reaches 1?
Yeah, we'll get to that one. Oh, 1.0. It says 1.0. Yeah, it's off your screen. So the amount, what was the amount? Maybe 2.5, right? And the R, I forgot. Everybody got that copied down there? The R is natural log of 0.88 over 24. So the R is natural log of 0.88 over 24. 24 times T. Oh, and what's the T? 48 hours, right? So there we go. So that's just hit the buttons on the. You don't need to clean anything up. That's just hit the buttons on the calculator. Find the amount of chlorine. So what's the amount of chlorine? Anybody got that number? 1.94? Good, thank you. Anybody else get that same number? Yeah, sounds right. Yeah, so the chlorine's going down and down, right? So that makes sense, it's lower. It was 2.5 originally, it was 2.2 after 1 day, now it's down to 1.94. The chlorine's going away.
That,
Question, David?
how did you get to 1.94?
Just type all that in your calculator. If you have trouble, grab me after. Does it make sense? I plugged in the R that we got from phase 1, and the time was 48 hours because they said 48 hours. So, but yeah, if you're having trouble getting that on your calculator, come see me after class. 1 minute. I'll be able to help you out with that. But yeah, make sure you bring your calculators to class and type these in because that is essential that you can do that. And it's not always simple, right? We're doing fancy stuff on the kid. We're doing a lot of really fancy stuff on our calculators. Okay, and then the second question, it says, well, it says, I don't know if I have time for it all. Maybe we'll try it. So has everybody got that down? I'm going to go to frustration. Second question, you can't read it on your screen. It says, when will the chlorine be 1.0? When? That's question 2. So question 2. So that means you got to use this formula again. But they're saying when, so they want you to find T. What is T? When? T. Time. What is the time? When the chlorine's 1.0. So put the 1.0 in for the A, huh? You want the amount to be 1.0, and you want to find the time when that happens. Does that make sense? So I'm going to go to a fresh screen. This is a long problem. It's a 3-screener. So we got the PERT, and the initial amount is 2.5. What was the R? It was ln of 0.88. What was that? I forgot. ln of 0.88 over 24, right. To the T. So there's our formula. And now I'm going to plug in when, so what is T when the chlorine is 1.0? So the amount is 1.0. And they want me to solve that for T. That's not easy. So I got to solve that equation for T, right? I put in amount 1.0, find T, right? The last question, they just told me time was 48 hours. I put in 48. Now they're saying find T when the chlorine's 1.0. So how do I solve that for T? What's my first step? Divide by 2.5. Is that clean? I think it probably is, right? What is it? 0.4, thank you. 0.4 is E to the ln 0.88 over 24t. Hey, yeah, remember the trick? Let's do the trick over here. It'll help. Remember how we do this? We just make it E to the ln 0.88, and the t over 24 is outside of that, right? Remember, you just move that 24 out here underneath the t. And then The E and the LN cancel. And it's 0.88 to the T over 24. Remember that? I think that'll make it easier. And we're trying to solve for T there. How do we solve for T? What do we got to do? Ln of both sides, because T's in power. T's in power again. Right? T's in power, so you know what that means. Ln of both sides, yet again. Right? And then the power drops down. I'm just running out of room. This is a long, long problem. Ln of 0.4 is T over 24 times Ln 0.88. Am I still on the screen? Yeah. Right? The power comes down, and then we can finish solving for T there. We good? Can I go to a fresh screen? I'll go back here. So this is the fourth screen on this crazy problem. Ln, what was it? So it's Ln of 0.4 is T over 24. Ln of 0.8. So everybody got that copied down? We good with all those steps? See what happened there? So I got this point. The E and the Ln canceled. With 0.88 as the base to the T over 24. Took the Ln of both sides, and it dethrones the power like it always does. T over 24 times Ln of 0.88. So then, all right, am I doing that right? Yeah. So now, how do we finish solving for T? Well, you need to divide off the Ln 0.88, right? For starters. We get to there. What's the last step? Just multiply by that 24, right? T's alone. Hit the button. Somebody got it? What's the time? It says nearest hundredth. Or I don't know, 0.03? What is that? 172.03 hours. What's that? 0.028, so around 0.03. Yeah, so that many hours until the chlorine level drops to 1.0. There we go. That was a long one. You okay with those? Questions on those? All right, I'm going to move on. All right, so logistic growth model. So this is a more realistic model of how things really grow. Those other models, the PERT ones, they were like if there's no predators. Did I mention that Tuesday? There's no predators, there's plenty of food, there's plenty of space. In other words, uninhibited growth. Right? I talked about the rabbits on islands, tearing them down. Right, yeah. So, you know, in real life, there's predators, there's limited space, there's limited food. So this is a more realistic model for how things grow called the logistic growth model. Anyway, whatever. We're not in a biology class. Enough said. I'll just tell you what you need to know. So they say find the carrying capacity. That's the number at the top. That means the most that can live in the environment. The space, basically. It's the number in the top. Okay. Next, what is the growth rate? Remember the like the PERT, for example? It's always next to T. The rate is always next to T. So the rate is right there, isn't it? Do you see that? It's the negative 0.424, but change to a positive percent. I'm not picky like that on the test. I don't care. If you just wrote negative 0.424, that's fine with me. They're going to be picky. They want you to change it to positive for whatever reason and move it to a percentage. So move it 2 times, 42.4%. That's what they want. But it's next to T. R is always next to T. That's the main thing I'm letting you know. Rate times time. All right. Determine the initial population size. That's a question you're going to run into a lot as you move forward in math and science. Biology, chemistry, physics, everything. Initial. What are you supposed to do when they say initial?
0.
Times 0. That means at the start, huh? That means plug in plug in t0. That's what it always means when they ask you about the initial for something. So that means you take this little formula and you find what's p of 0. So that means, okay, let's see. 4,000 over 1 plus 30.1 e to the minus 0.4240. I plugged in 0 for time right there. Everybody tracking with me? That's what initial means, time 0. So I plug that in. Now, what is anything, including e, anything to the 0 power? 1. So this is 1. So this becomes 4,000 over 1 plus 30.1 times 1. In other words, it's 4,000 over 31.1. Which, that's why I asked you to do that in your calculator. That becomes the 129 when you round it to the nearest whole number. Does that make sense? So initial means time 0. That comes up a lot in math and science word problems. The rest you can do. 5 hours, plug in T5, right? When's it 3,200 grams? That means the left side is 3,200. Well, that's a little ugly. Oh, I just don't have time for everything. I guess we could do that. That means when will the population, that means the P is 3,200, and you have to solve that. Yeah, it's not easy, I guess. Maybe better do that. You guys got that copy down? I'll go to a fresh screen and do that, and we'll be done with this problem anyway. So I'm going to do part E here. When is it 3,200 grams? So you got to take this equation and put 3,200 in for P, right? Population, 3,200. So that becomes 3,200 equals 4,000 over 1 plus 30.1 e to the minus 0.424 t. Like that? We got to solve that for t. That's not easy. What should I do? Yeah. Yeah, I just put this over 1 and cross multiply. Same thing. Yeah, multiply by the denominator, basically, you're right. Yeah. Does that make sense? Whenever you have a whole number one side, fraction of the other, put it over 1, diagonal, cross multiply. So we get 3,000 times 1 plus 30.1 e to the minus 0.424t equals 1 times 4,000. We good to there so far? Yeah. I'm sorry. Oh, 3,200. Yeah, thank you. I am messing up. It's 3,200, isn't it? Thank you. Good. Good so far? And without repair? So diagonal, right? When you have a whole number on one side, fraction on the other, put it over 1, diagonal, cross multiply. Now distribute. So 3,200 times 1 is just 3,200. 3,200 times 30.1. Somebody get that for me in a calculator? It's going to be 9,6 something big. 9,6,320. Thank you. E to the minus 0.424t equals 4,000. We good to there so far? I just distributed through those parentheses. Is that okay? How we doing? All right, now how do you solve for t? What's that? Subtract. No, you got to get the base alone first. We're not ready for natural log until the base is alone. So subtract that. 96,320 e to the minus 0.424t is, what's that, 800? We good to there so far? How we doing? Are we ready for natural log right now? Base is still not alone. We got to divide by the 96,320. Boom. Then we're going to L in both sides. Now that number on the right, it's probably ugly. I don't know. Maybe it's not ugly. What's 800? Is it a decimal that ends or a decimal that goes forever? Oh, it's a decimal that goes forever. So I don't want that. I'm going to leave it as that fraction. Is that making sense? So you don't want to round in the middle. Everybody seeing where we're at? Can I go to a new screen? You got that copy down? You basically just need to do ln on both sides now. Leave that fraction on the right. Does everybody see why I'm saying that? whenever you divide any fractions in the middle of a problem and it comes out a decimal that goes forever, then just go back and leave it as a fraction. Because you don't want to round. And if it goes forever, you'd have to round. You don't want to round in the middle of a problem. You don't want to round a decimal. So just leave it as the fraction 800 over 96,320. All right, so we're almost there. Let's go back. So 800. So it's e to the minus 0.424t. So it's e to the minus 0.424t is what? 800 over 96,320. Okay, and at this point we do L. Now the base is alone, isn't it? See how we got the base alone? Then you do ln to both sides. So this power dethrones the power. 0.424t ln e is ln of 800 over 96,320. ln e is just 1, that's gone. Last step, we're almost there. Divide by the minus 0.424. Boom. T's alone. Now hit the buttons on the calculator and get an answer. Everybody got it? What is it? Is it rounded in its whole number? So just 11, huh? Anybody else getting that? 11? All right. Let's go type it in. See if it's right. Questions on that? We good? That's a lot of work, wasn't it? You can master that though, but it just takes time. It really does. I know the last exam was hard for a lot of people. You know, math and science, really there's just no secrets. It's just repetition, a lot of repetition. I had to. You know, there was a time in my life when I couldn't do this, right? And now it's like tying my shoe because I'd done it 10 million times, right? I mean, it's really that simple. It really is. You have to give math the time it wants. That's what I found. That was my experience. You know, I took GE classes. Like I said, I enjoyed history and I enjoyed really all I liked psychology too. I thought it was interesting. But anyway, I had to spend way more time on my math and my science. I just did. I think everybody does. So anyway, so if you're discouraged, I'm trying to encourage you. And you know, with we have 2 more tests in the final. You can totally pick up your grade. You can totally pick up a good grade at this point. In fact, I let the final replace the lowest score among the 4. So if this one was your only low score, you can still get a really high grade. But the final's not easy. That's not a handout. That's an opportunity. That's an opportunity to learn what you did not know. Because all that stuff will be on the final. And the final's hard, not in the sense that I'm putting harder problems. I'm not. But it's just everything at once is hard, you know. Scores on the final aren't usually great. Because it's hard to remember everything. But anyway, having said all that, you know what? I think I've told you. Have I told you what my sweet wife used to do when she took math classes? Is she'd do all the problems 3 times. 3 times. She would think the practice exams thing, that's not nearly enough practice. Not nearly enough. So I just want to let you know that's what people are doing who are doing well, and that's what I had to do. And I'm a math person, right? You probably think I just popped out of the womb knowing math. I did not. I did not. I had to, I mean, I was good at math from a young age, but I had to work hard. I really did. I would never dream of not doing all the homework. That would just be crazy to me in a math class. I mean, you're just asking for a failing grade. It would be my opinion. I would see my teachers all the time, asking them questions, every homework problem. I made sure I understood every single homework problem and could do it on my own before I took a test in any math science class. Well, one time I took a physics test and did all the homework the night before and got a flat F on the thing. And then I learned the big lesson. You could do that in history and psychology maybe, just study the night before and it's okay because it's just a little more natural, common sensible. But math's like Chinese or something, you know, it's painful. So anyway, long story short, if you want to do well, go back over that homework. Go through the homework once. I'm talking you through every type of problem, right? Use the YouTube and listen to me explain how to do the problems. Any problem you're stuck in, just do them. You can ask for new ones. You can go back and ask it for new ones that won't lower your grade. There's a go back and practice thing, right? You can ask it for new ones. Do them again. What my wife would do, I didn't work quite as hard as my wife, but I did all the homework once and made sure I really understood it before an exam. Every homework problem. I could do any homework problem before an exam. The teacher would have thrown me a homework problem. I could do any of them before an exam. My wife would do them twice. So she would do them once like normal homework to 100% level, and then about a week before an exam, so a week before, we're about a week out now, week and a half from this exam, she would go back and do all the homework from every section on that exam. She thinks it's silly I do practice exams. She's like, practice exams? That's not nearly enough practice. right? And I've got people that don't even do the practices. At that point, you're just not, that's just not going to make it in math and science. I mean, really find some other major if you're not willing to do that. I mean, that's just the truth. Math and science, you have got to be willing to work like that. So I don't want to discourage you, but I want to tell you the truth as well. That's what it takes to make it in math science. You can do it. You know, you really can. Most people can do it if they're, but it's about putting in that time. And I know the reality is, I've talked to enough students over 24 years of teaching. I'm getting old now. And they tell me, Mr. Heron, I'm working 40 hours a week, and I've got 2 kids and this and that. I know. I mean, I know that's reality, but I'm just telling you that won't cut it in math science. Maybe a math science degree is not for you if that's the case. I'm not wanting to discourage you. I'm just not wanting you to have a bad experience of trying something and then having to ditch it and do something else. So the reality is, if you want a math or science degree, you have to be in a life situation where you can give a ton of hours to your math and science classes. That's just what it is. You got to redo the homework. You just got to redo it and redo it and redo it until you can do it. That exam, I could show you that exam. Every one of those was a homework problem. I could go back with you, and I could show you every one of those is like number 23 and this that I talked through. So the help was there, and it was no surprises. That exam was exactly homework, but it's about putting in enough time to master that. So, yeah, Alberto.
On the final, do you get your problems from the test?
Not the exact problems, but one's just like it. Yeah, it's just like it. I'll tell you, go back over your old exams. It's the best way to study. I'll take like half the problems, not the exact ones, but one's just like it. Change the numbers.
Test to study?
Yeah, absolutely. In fact, what I'll do is I'll put the keys up right before the final. I'll put the keys up from all the old exams, all the answers, and I'll say, just go back over your old exams. Don't even look at Math Excel homework. Just go over your old exams. I'll put all the keys up there. Hopefully we'll have one day to review. You know, I'm always pressed for time, but we'll do what we can. But I'll put them out there, and that'd be the best way to study for sure. Yeah. Okay. So 10.2, the parabola is not on the screen. Let's try to get it on the screen there. Hello? When did it go off the screen?
Just right now.
Just right now, huh? No signal.
Like right before you turned it on.
No signal, it's saying. I'm looking for a signal. Let's try again.
No.
Try this. We're having a I think it's that thing's having problems. Because my laptop's doing fine, and this thing won't turn off. It won't do anything right now. It's mad. Yeah, it's not doing anything.
To see your screen.
I could, huh? It's not a bad.
I mean,
Oh, but I
it's
can't
on
project
YouTube,
anything.
though.
This thing won't let me project anything.
Oh, right.
Oh, it's doing that thing it did a couple months. I got to call those tech people. Yeah, I got to call for help because it like gets into a weird. It's just mad all of a sudden. Yeah, it won't turn off. It won't do anything. Where's that number? Sorry, hold on. And then I'll just start. Your question a lot. I'm glad people are thinking about that. Yeah, let's talk about it. Yeah, so here's the question. Bunch of multiple choice options. Yeah. So first off, again, it's negative.
We're not seeing anything.
What in the world is it doing? Okay. There we go. All right. Technology's wonderful. All right. So x squared is negative 4y. So back to that again. Now, yeah. So remember back when one of the second week of the course, right? We talked about shifting graphs and stuff, right? That's what Alberto is referring to. Probably what a lot of you guys are thinking in your mind, and I'm glad you are. Let me tie up a couple loose ends there. You remember like back when we had y equals x squared, right? That's the U shape, right? But if you put in like negative 3, what does that do? It moves it right 3, and then the U shape's over there, huh? Remember, x is always the opposite, we learned, but y was the same, which is what you're hitting on, right? Remember how we learned that? You guys remember? Let me draw an example. So for example, remember back in those days when we were first graphing, it wasn't just for x squared, it was for any of these graphs. When we were graphing, how would you graph x plus 1 squared plus 2? We know it's a U shape, but what would you do what would the 1 and the 2 do? Remember? Remember how those work? Yeah, it'd be right, or no, left, huh? Because x does the opposite. X does the opposite. So it'd be left 1, and then this would be, and the y does the normal. Up 2 would be right there, huh? And then you do your U shape centered right there, right? Remember that? Remember how x was opposite, but y was always same? Did it ever bug you at that time? Did you ever go home thinking, why? Why is x opposite and y is the same? Why is there this magical difference between x and y? Well, now it's time to answer the question. There is no magical difference between x and y. It's just the form that we had the equation in. In other words, see what we're doing now? I'm telling you what the answer to this is x, well, at least the first part, is y minus 1. See what I'm doing there is I'm taking the minus 6, 1, which is the center, opposite.
Don't we use the y squared on this one?
Yeah, I thought so too. Isn't it the y squared?
Oh, I'm doing it backwards. Thank you. I just did it too quick, and I am wrong. Thank you.
You started
It's on the board even, huh? So let's try it again. That's negative 4ax, huh? Thank you. Because it's back. It's left. Negative x. Thank you. Anyway, so going back to the line, y minus 1 and x plus 6. I'm telling you now, I'm changing my story, but really there's a deeper story which fits both. But I'm kind of seeming to change my story. I'm saying, well, now both x and y are opposite. Which is not what I used to say, right? I'm saying whatever you have next to x, negative 6, put that next to x opposite for the center. And whatever you have next to y positive 1, put that next to y opposite. When it used to be, x was opposite and y was same. Why? Where was the number? Was it next to y? What if we had moved it over next to y? You see, it's just how we were writing. It's off that dang screen. I'm tired of technology today. All right, so it's just the same. It's because we were putting y alone back then. That's all. See, if you moved that over next to y, it would be opposite for both, wouldn't it? It would be back 1, up 2, which is opposite. So the real story is, when a number is right next to the x or the y, the letter doesn't matter. When you're right next to your letter, you're always opposite. Because if you moved it to the other side of the equation, when it would equal that, it would be the opposite. That's the real story. We were just putting y alone back in those days. We're not putting y alone now. All right, so there's the deeper story. I'm glad you asked. So you look at this and you go opposite, because it's right next to x, right next to y. There's my equation, except I don't know a. Can I get my hands on a? How can I find a? Well, I don't even need to, I don't think. I think that's enough to grab the right option. So which one of these is y minus 1 squared? Isn't it got to be b? What else has y minus 1 squared? It's not e because that's a plus 4, not a negative 4. And yep, that's it, b. Enough information. We don't even need to find a on this one. If it's just b, good enough. We'll get into the a stuff here in a second. Does that make sense? How I grabbed b there? It's negative 4. All right. All right, so try that one. So first thing to decide, is it up, down, right, or left? Up, down, right, or left, and write the right equation for up, down, right, or left. So, right, let me write those out one more time just so it's saved. So up, down, right, and left. The basic equation when it's going up, that's positive y, so it's x squared is positive 4ay. When it's down, that's negative y. So that's x squared is minus 4ay. That's what ours is. When it's to the right, that's the positive x direction, so it's y squared is positive 4ax. It's all about the first power letter. The first power letter, like x to the first, y to the first here, y to the first here, tells the direction, doesn't it? This one is negative x, so negative 4ax. Going to have to look at that screen. Is y squared. All right, so it's which one? It's this one, because ours is going down. So it's x squared is minus 4ay to the first. Now the center is 2 negative 6. That's opposite, opposite. So it's x minus 2 squared, y plus 6. There it is. And that's probably enough to grab the right option. It's enough for now. They're not even messing with the a. Good on that? Not making sense? Chloe Keys? All right, so they want me to find the equation of the parabola. And they're giving me some information. They're telling me the focus. And the vertex is 0, 0. That's the center. The vertex is the center. So this one's centered at 0, 0, centered at the origin. The focus point is at 3, 0. So it's 1, 2, 3, 0 right there. There's the focus point. Now, what is the focus point? Let's talk about that. Let me give you reality first. See, parabolas, these U-shapes we're dealing with, parabolas are a certain kind of curvature. They're a certain bending. Do you guys know satellite dishes on people's roofs? Those are, that bending in there is, they're called paraboloids. Technically, they're three-dimensional parabolas. These are flat, two-dimensional, right? The three-dimensional satellite dishes are paraboloids. They are bent just right to bounce everything to the receiver. So, in other words, let me draw a little satellite dish, flat, two-dimensional. Have you ever noticed there's like a receiver? There's little arms holding a little receiver right there. What that means is, how that works, is the curvature is bent just right so that when the beams come down from the satellite in space and they hit, it bounces it straight to that receiver. Wherever the beams hit, they're aimed, they're focused. That's why it's called the focus point, right at that receiver. The engineers have calculated right where that focus point goes, that receiver goes, it's held right there in the right spot. And the bending of the parabola, it's bent just right. You guys are moving on into calculus now. You want to start realizing there's different kinds of curvature, right? I could drive my car and I could turn the wheel and hold it in such a way that I would perfectly come right back and make a circle, or I could hold it more tight so that I kind of go like that, or I could hold it less tight so that I go out like that, right? There's different kinds of bending rates, aren't there? There's different kind of curvatures, and parabola has a certain kind of bending, and other shapes have different kind of bendings. So parabolas are curved just right to aim everything at their focus point. This is how your headlights work on your car as well. They put a lamp, they run it backwards. They put a lamp right here, and the lamp shines back on the mirrored surface, that inside of the headlight, that is parabola curvature in there. And so it shines back and aims it straight out. It's just running the satellite thing backwards. Flashlights, headlights, searchlights go up in the sky, same thing. They have the lamp at the focal point. So that's one practical use of parabolas. So having said all that, that's what they're talking about when they say on this problem, here's the focal point, here's the center. So what that means is the parabola is going to the right, because the focus point is always inside the parabola. So we know this one's going to the right. So with that in mind, what's the basic equation? Positive x direction. So that's the first power letter. Remember, the direction is the first power letter. So that must be y squared is positive 4ax to the first. Good so far? Now, what is the a? Now it's time to talk about what that a is. What is this magical a floating around in these formulas? That a is this distance right here. A is the distance from the center to the focal point. Well, I'll just say the focus. from the center to the focus. That's what engineers have to calculate, and that's what we'll calculate in one of our questions at the end of the section. So that's the A. It's how far from the center to the focus point. So how far is it from the center to the focus point in our example? It's 3. So the A is 3. So this is y squared is 4 times 3 times x. That 3 is just, that 4 is just always there as part of the formula. 12x. So where is it? It's answer C. Y squared is positive 12x. We good with that? Does that make sense? Questions on that? Can I keep moving? Okay, so again, I'm drawing pictures on all these. Pictures are not required, but I think they're super helpful. I would suggest you do that. All right, find the equation of the parabola. Find 2 points that define the lattice rectum. Oh, we'll get to that. And graph the equation. All right, focus is at minus 1, 0. I'm going to make it even bigger, I think. Focus is right there, minus 1, 0. Directrix line. Now, what's the directrix line? Let me put it on there first, and then I'll tell you about it. Directrix line is like an asymptote line, kind of. It's the directrix line. It's hitting the x-axis at 1. This one's back 1, this is the focal point. The directrix line is a dotted line on the parabola graph, not because it's an asymptote line. It's not. In other words, the graph is not going to get close to it or anything like that. It's not that kind of dotted line. We put dotted things on graphs, not just for asymptotes, but for any part of the graph that guides the graph, but is really not part of the actual graph. So the directrix line is dotted because it's not really the graph. It just guides the graph. How does it guide the graph? It sits behind the parabola. So the parabola goes like this. The directrix, you know the focal distance is A, right? A is how far from the center. Well, directrix line is the same distance to the other side. Well, in this case, it's 1, isn't it? It's back 1, it's forward 1. Huh? Let me say that again. The center of the parabola is always right in the middle, 0, 0 in this case, right in the middle between the directrix line and the focal point. Center of the parabola is smack in the middle. From the center to the focus is called A. Back to the directrix is also A. It's the same distance either way. It's right. The center is right in the middle between those two. So, with that in mind, so that means, for example, what if you have a parabola going down? The focus point would be here, and the directrix line would be back there some way, same distance other side. Does that make sense? The directrix line is always behind the parabola, directing it. The focus point is inside the parabola. Everything's focused on it. Now, I don't have time. I don't have time for lots of things in this class, but it seems like. But I don't have time to show you. I'll just say this. What the directrix line is, see, I always want to say something, then I run out of time, huh? If I just think for a minute, what if we had an axis system and I said, hey, here's a line and here's a point, focus, directrix, and I said, hey, tell me all the points that are equidistant from that line and that dot. What are all the points, all the dots that are exactly in the middle between this line and this point? What are all the dots that are halfway between this line and this point? For example, if I was at this dot here, am I halfway between the line and the F? No, it'd be here, huh? Right? That's one dot, not this one. But are there others? Well, how about like here? You think, well, yeah, it's just all those on the line. No, not that one. Because this one is closer to the line than he is from the focal point. So he's not fitting that. Well, okay, I see that. So then what's another point? It's more than just that one at the origin. You'd have to bend it over a little bit. Right, like there, wouldn't you? Now that looks like about the same. Maybe I've exaggerated a little bit. It'd be something like that. You'd have to move to the right a little, maybe here only. You'd have to move to the right a little bit, wouldn't it? To be same distance from the focus point as it is from the line. And on and on and on and on and on you go. That's what a parabola is. The parabola is the set of all points who are equidistant, same distance from the directrix line and the focal point. They together generate the problem. All right, so that's all I have time to say on that. If you're interested, I'm interested. I would love to talk about it with you in my office hours, and I'll show you how they derived it and where the 4ax came from. It all has to do with derivations. Hold on, I need this minute. All right, so let's finish up this problem here. So that's all I can say about derivation. Come see me, I'd be glad to go over that with you. But let's go on from here and finish this problem up. So it's going to the left. So this is then minus 4ax, minus x direction. Y squared is minus 4ax. And what's the a? Oh, it's just 1, huh? So it's y squared is minus 4x. Is that good? Yeah.
So the a can never be negative, right?
There's two different ways to do that. And both are fine. In other words, some people look and they go, well, in the end, there's the equation. How did that become? Was it a negative 4 times a positive 1x? Or was it a positive 4 times a negative 1x? And then the a is actually considered negative. I don't care. It's whichever way is easier for you to think about it. So I'm answering your question like you can think about a being negative if you want, or you can always put the sign on the 4 and then the a will always be positive.
Does it say since the parabola is pointing to the left, so there's a negative?
Yeah.
A negative one?
Yeah, so a is negative 1.
Even though we just did it.
Well, it's because I already put the negative here. So in other words, the a can be negative if you're considering the 4 always positive. Am I making sense? I wouldn't stress myself out about it. That's the kind of stuff that can really get you messed up. Just think in the end, hey, if the thing's going to the left, then this is going to end up being negative over a. However you do it. Whether you put a negative on the 4 or you put a negative on the a, it's got to be negative in the end. It's going to the left. Nothing easier, I think, to deal with than worrying about more particular things, because there's options on that. All right, well, that was quite a day. We didn't get nearly where we're supposed to get.
Question, because